Yay. See people coming on. So, hi everyone. We'll give it just a second here as people are joining us. We got 11 o'clock, so we'll give it just a few seconds. All right. Well, I think we'll get started. I want to thank Eric Snodgrass for joining us. I'll give a brief intro to him. So I'm Matthew Cruz, president of Comstock Investments. Eric probably needs no introduction, but I'm going to do one anyway. So Eric Snodgrass is the principal atmospheric scientist for Nutrient Ag Solutions, where he develops predictive analytical software solutions to manage weather risk for global production agriculture. So Eric, I want to thank you again for joining us, and everyone's always real interested this time of year, of course, to know what the spring planting weather is going to look like. So I'll hand it over to you, and we'll get started.
All right, good. Well, we'll get that question answered hopefully here pretty soon. And I appreciate everybody carving out some time this morning just to hear what I've got to say about the weather, and we'll dig through it. But as we go along, questions, just get them fired off. Let's get the questions answered here. Make sure I cover the stuff that
and we will be recording this too, so we can send it out later. But yeah, as he's talking, if you have questions, go ahead and fire those off, because I know they can sometimes take a while to type in. So there is a Q&A box there at the bottom of your screen. So
perfect. All right, I'm gonna just stop sharing my face and start sharing my screen. And I really appreciate just a chance to get to talk to everybody today. I've got a new spring talk I've been trying out for the last week, got a lot of new updated information in it, but I'll tell you something, tomorrow is a big day in atmospheric sciences, because the 5th of every new month, we get long range weather updates from the European model. So if you want to see what those look like, they'll come out tomorrow night. So it'll be in my report that'll go out on Thursday morning. But there's a web link down there at the bottom. It's a completely free daily weather newsletter I post via email. We're trying to make some changes to this to get away from email, because email annoys a lot of people. So we're trying to get this over to almost being delivered as a web application for you that can show up on your mobile phone. But just down there at the bottom, info.nutrient.com/Snodgrass_weather. Just 5 days a week, I pump out a weather forecast in the morning. I designed it to be glanced at. Just look at it, take a look, make sure there's nothing in there you need to know about, and then delete it, because I'll do another one the next day. But I told you a little bit of a new spring talk, and my title of this presentation, I think you're going to see why I care so much about this, is that I call it Hunt for the Anti-Cyclone. Now, I realize that some of you are listening to me today from the state of Iowa. This has nothing to do with Iowa State. Hunting for an anti-cyclone here. This has everything to do with the weather. So I want to make sure I don't get any of you angry at me to get started here. But here's what we're talking about today. This was back on March 24th. This was just as the sun was setting here over the southern plains of the United States. And you see a few different things here. There's a big area of dust blowing in this part of Texas. There's a massive line of storms going over the Mississippi Valley right here in the lower Mississippi Valley, and a storm system that's all spinning up. And if you notice, the rotation of this storm system has a flow to it like this. It is it's counterclockwise. And back on Friday, the 24th of March, we had a massive outbreak of severe weather down south. And on radar here, you can see those storms ripping through parts of Mississippi. They were all in the tail end of that big spring storm system. This is a storm system that ripped through Mississippi. It actually killed well over 20 people and did a tremendous amount of damage and destruction. If we look any closer at some of these individual storms, I'll take you to Northwest Mississippi. When you watch this animation, it may not look like much when you first see it, but let me point out a couple of interesting things. I'll pause it, I don't know, right about here. What you've got as we're heading toward a town called Amory is one of those supercells. Can you actually see the storm kind of curling around like this into a little hook right there? That's called a supercell. All of this is down the rear flanking line of this storm, but right inside here is where this one was producing a tornado. But take a look at the direction it rotates. Just like the bigger storm system around it, it curls around in this counterclockwise motion. We can even use radar, modern radar technology, to not only look for shapes like this, but we can actually use what's called Doppler technology to measure the wind speed and direction. So I'll kind of pause this just as the storm is over Amory. And do you notice the blue-green here, and then the reds here? This just tells me the storm is curling around just like this, and that's the rotation inside of what we call the mesocyclone, the big rotating part of the storm system. A week after that, this was now last Friday, this storm system blew up across the midsection of the country. And this is one for the record books. As you watch it here, there was a blizzard on the northern side, here in parts of South Dakota, Minnesota, northern Wisconsin, a substantial severe weather outbreak that stretched from Iowa all the way down to western Texas and points east of there. And then on the backside, we had another massive dust storm. Watch right here where I'm pointing. All of that's dust, except for in Oklahoma, there were a couple of large fires, showing you how dry the backside of this storm system was. Once again, what do you see? The system is spinning up in a big counterclockwise direction. We're going to come back to that idea in a few moments here. But take a look. Right now, we're approaching 1,000 reports of severe weather from that one day, March 31st. And don't forget, the next day there was severe weather here. And then on Sunday, we had severe weather down in this part of Texas. This is only one day. This is Friday. 142 reports of tornadoes, 957 total reports of severe weather. And this is going to be a system that we remember for a long time. Now, I could spend the next 55 minutes just showing you pictures and videos of what some of those tornadoes look like. But I just pulled this one. This is from a friend of mine named Stas. He allows me to show his videos and my presentations. What you've got here is he's actually in the wrong spot of this storm. He knows it. That's why he's driving so fast. But this was the large tornado outside of Martinsburg. And I'm sure many of you have seen dozens and dozens of videos of what these things have looked like over the last few days here as we kind of just think back on the high impact storm system on Friday. But it's just a reminder that we're in that time of year where the atmosphere just loves to overturn. We call it spring. And what it can deliver are some powerful, powerful storm systems. So here we are. It's Tuesday, and this is what I'm dealing with today. I pulled this off this morning, but this is our latest, what we call all hazards weather map from NOAA. And I just want to point it out again. We have 5 states with blizzard warnings in them right now. This is all red flag warning. We're going to watch the high wind advisories spread throughout this entire area over the next 2 days. There's cold enough air on the backside to bring a frost to the Sacramento Valley. And later on this afternoon, I expect tornado watches to be issued here and also probably down into this part of Arkansas and southern Missouri. And we're going to watch this storm system race on off to the east tomorrow. In fact, almost like a repeat of last Friday, we have our severe weather outlook on the left today. 2 areas of moderate risk here and here. That's the second highest risk category that the Storm Prediction Center uses. And then as we get into the day on Wednesday, that storm risk is going to open up for much of the Eastern Corn Belt. Now, if I could say there's one good thing about this, we don't have a lot of crop in the ground right now. There are people that have gotten out and planted, but right now there's not a lot of crop in the ground to be destroyed by this. So this is just going to impact homes and farms in a way that it might destroy some infrastructure and just add to the severe weather threat that we all had to deal with last time. Don't forget, there's always 2 sides to these big spinning storm systems. And the northern side is looking like this in terms of snow. Coming out of Wyoming, stretching through South Dakota up to the Red River Valley of the North and most of the northern half of Minnesota, we got a pretty large swath of somewhere between 6 and 18 inches of snow right in through this area. And in my presentation today, we're going to be talking about what this snow means, how quickly it can melt, and what that might do to the upcoming growing season. Also, I know it's not here in the US, but I want to let you know that coming into Lake Superior and then a big chunk of Ontario and Quebec, and then back into the US here in Maine, we have the chance for picking up a lot of ice from this system as well. You stitch it all together and you get this. This is a forecast for the next 60 hours of the size and strength of this storm system that's going to rip through. And it's got a major severe weather threat to it. It's got heavy rains and flooding down to the south and a blizzard up here to the north. Now, the good news about all of this is that this is the last one you're going to have to deal with for possibly maybe a week. We're going to get away from these for the next week. But every time we get into spring, the atmosphere loves to just build and propagate these massive storm systems across the United States. And did you notice every single thing I've talked to you about so far, they all spin in the same direction. Now, here's what I want to do for you today. Okay. I've got 50 minutes left. I want to make a case for why we look for storm systems like this. But when it comes to the weather that is most impactful, to U.S. agricultural productivity, it's actually the systems that spin in the opposite direction. We call these cyclones. Today, we're going to go looking for anticyclones. Now, we have to blame this guy for giving us the first thoughts on why in the world our storm systems spin. I say blame because this guy and his discoveries meant that my education was absolutely chock full of mathematics to try to understand how these storm systems spin. He's a French guy by the last name of Coriolis. He studied mechanical engineering. He was not an atmospheric scientist. And what he really cared a lot about was the way that water seemed to have what we call apparent forces that showed up when you had it moving across a rotating reference frame. Now, what am I talking about here? He studied and built what are called water wheels. And as he was building these things, he found that as the water moved on that wheel, while the wheel itself was moving, the water behaved in very interesting ways. Now, he had no idea that later his research would be applied to other people. And I want to show you what I'm referencing here when I talk about the movement of an object on a rotating reference frame. Back in 2006, I was a professor at the University of Illinois. This is my teaching assistant. Her name is Amanda. And right here in her left hand, she has a baseball. And I asked her, while we videotaped her on one of the lone surviving merry-go-rounds in Champaign County, Illinois, to push that baseball out to her side, and let's see what happens to it. She's not spinning it, she's just pushing it. But because the baseball is moving on a rotating reference frame, the merry-go-round, it experiences apparent forces. It turns. And in this case, it's constantly making a turn to the right. Again, all she's doing is just pushing it, and it comes out there and curls around. Now, you're probably going, what in the world is this dude doing? All I want to know is if I'm going to be able to plant my crop this spring. Okay, I get that. But everything that she's demonstrating for you right now ultimately determines in the atmosphere whether or not you're going to open up a nice planting window. Because what she's demonstrating is how weather systems spin. And we got to get them to stop spinning up cyclonically around us and start spinning anticyclonically. Got it? That's what we're going to study. Now, that term I keep coming up with, cyclones, cyclonically, we got to thank this guy, Henry Paddington, for it. He was a British sailor and merchant, and he is the one that anglicized the word kukloma, which was Greek, and made it cyclone. It was a word that was once used to describe how snakes coil up. Now, what he did was he wrote a book after traversing the world's oceans called The Sailor's Hornbook for the Law of Storms. And in that book, he built this diagram. Now, what he calls it is a storm card, and he's referencing the way that winds circulate around a low pressure system. You can see he's actually got cardinal directions on here as well, north, south, west, and east. And the flow goes in this direction. What he was attempting to understand here was that depending on where you are with respect to the center of these storm systems, you could expect different types of conditions. But every time the atmosphere spun up below, which gives us all the inclement weather we deal with, they're going to spin in this direction. Now, while some of you are thinking about it, I just want to go ahead and get rid of this myth. This is not the reason why water in your toilet bowl flushes in a given direction in the northern hemisphere versus the southern hemisphere. If I were to take that toilet from my house and ship it off to Australia and have it flush down in Australia, I promise you the water will spin in the same direction. And that's because on very, very small size scales, the rotation of the earth is negligible. If it could affect the direction that the water rotates in a toilet bowl here, you'd feel it all the time. You couldn't throw a ball straight. You couldn't putt a ball across a green straight. In fact, you couldn't go bowling and throw the ball straight if the Earth's rotation was an impact of this. In fact, you couldn't even drive in a straight line. There's all sorts of things that at small scales doesn't work. And you're going, why is Lisa Simpson on this slide? Well, believe it or not, there was an entire Simpsons episode dedicated to this, although they had the science completely wrong. But I don't have time to go into the Simpsons. What I have time to talk about to you today is about this. This is actually an animation of our most recent Category 5 strength hurricane. Just this week, a news report came out that we reanalyzed this storm system called Hurricane Ian and found that it did maintain Category 5 strength winds over 155 miles an hour at one point. So it's now been reclassified as a Cat 5. What you're watching here, though, is a radar animation. And as this storm hit Florida, I'm going to be honest with you, I thought that in the days leading up to this, we were going to see our nation's first, well, possibly $500 billion to $750 billion weather disaster, maybe $1 trillion. You're going, what are you talking about? I'm talking about Tampa Bay. Had this hurricane, which all of them in the Northern Hemisphere rotate counterclockwise, cyclonically, had gone to the north of Tampa, it would have pushed a wall of water into Tampa called storm surge, where each successive wave is deeper than the one before it, totaling up to 10 to 20 feet. It would have flooded out over 3 million people and destroyed a lot of property. Instead, it went south, still doing a tremendous amount of damage, but you can see here that the winds came from the land offshore. And as a result, it pulled the water away from Tampa Bay by up to 1,000 yards. And people went out there trying to see if they can find stuff in the newly receded water line here. But I'll remind you of something. Should you ever be somewhere where this happens, the water does come back. But at these point these pictures were taken, we just saw it out there 1,000 yards away, all because these storm systems spin cyclonically. Hey, one last bit of trivia for you here. Take a look at this. This is a map where there's a little squiggly line showing you the direction and path of every single cyclone, tropical cyclone, called hurricanes, called typhoons, all over the world. And do you notice how none of them have ever crossed the equator? They can't. It's impossible for them to cross the equator because in order to do so, the whole system would have to stop and then start spinning in the opposite direction. So where we live in the Northern Hemisphere, they all spin like these monsters. Take a look at this. January 3rd, 2023. That storm system right there was about to slam into California. It was one of over 30 storm systems that hit California this winter. This was one of the biggest, though. This one, just so you understand, you could put 12 Hurricane Ians inside of that system. These non-stop cyclonic storms slamming into the West Coast have completely relieved the area of drought. Looking at the drought monitor class change over the last 12 weeks or 3 months, we've seen up to a 5-class improvement in California, which means for the first time in a long time, California is out of drought. They would have loved for all of these to have stopped at the end of January, but March came through and continued to deliver more snow. And if you look at that graphic over there on the left, this shows you today that there's between 30 and up to 120 inches of liquid in the snow. I'm not talking about the snow depth. I'm talking about when it all melts. There's between 30 and 120 inches of liquid in the snow. So the spring flooding throughout California's Central Valley coming off the Sierra Nevada mountains, I'm talking about right here, is going to be bad this year. Very, very bad. If you look over here, this map on the right shows you snow water equivalent. Some places have had 2 to 4 times the normal amount of snow this year than they normally get. That's 4 winters worth of snow some places have received. And just so you know, the upper Colorado Basin, which is right here, which feeds the Colorado River, which goes through parts of Arizona, Nevada, cuts through California, and then out down here into the Baja of California. That river upper basin right now has got 150% of snowpack on it. So for the first time in decades, we might actually see the water from the Colorado River make it to the Pacific Ocean. That's how much snow is there. A couple of pictures I pulled off in early February. So this is before all the March snow. I asked Sarah in the Sugar Bowl Resort for permission to show their pictures here. This is what the snow looked like around Tahoe. And they just almost doubled that in some places here in the last 30 days. The Western United States has seen a tremendous amount of water. Before this, Lake Oroville was near record low. After this round of precipitation in January, it came up like this. And most recently, Lake Oroville's water levels have come up over 200 feet in depth. And that lake, one of the biggest reservoirs in Northern California, they're having to let water out of it because if they don't let the water out now, they'll have much bigger spring flooding problems on their hands in the coming weeks and months. And that's because Lake Oroville is currently at 116% of its historical average. And there are only 5 remaining reservoirs in California that are not above their historical averages. But what we know right now is all of that moisture will be coming out of those mountains And as it does so, it's going to fill this up. Now, why do we care about California? Leads the nation in the production of over 40 different fruits and vegetables plus milk. It's got 40 million people, tremendous demand on their water resources. For the first time in a very long time, their reservoirs are full. And instead of just staying full, they're going to have a major flood fight on their hands going forward into this spring. That's going to heavily impact some of the most important crops in the country that many of us buy in the grocery store. So we need to watch out for this and its impact very carefully. Now let's come back to the Midwest. Back on Valentine's Day, this was the Valentine's Day storm system. You can see exactly the same pattern I've been telling you about. They spin up counterclockwise. And on the northern side of every one of these systems, which has come through California, out of Colorado or New Mexico, and then run up toward Lake Superior, on the northern side, we've been putting down just tremendous amounts of snow. Let me show you where we stand. This is season to date snowfall in terms of total accumulated inches. We've got places out west that are up to 800 inches of snow in the Sierra Nevada. That's over 66 feet. And when you come back into the plains, if we zoom in on that area, I just want to show you that the plains and Midwest, we have parts of North Dakota, South Dakota, Nebraska, getting into Minnesota, Wisconsin, UP, and Michigan. There's a stripe in here that so far this year, we've had 70 to over 100, almost up to 200 inches of snow when you get up here into the UP of Michigan. It's often better to look at these maps by comparing them to normal. So that's what this map does. It says, what's the deviation from average? And if we zoom in here again on that same area where you see those positive numbers, some places have had 3 to over 6 feet of additional snow this winter compared to average. Whereas in parts of Iowa, Nebraska, Kansas, Missouri, Illinois, Indiana, Ohio, we have a lot of negative numbers in there. I mean, where I live right here in Champaign, our number is minus 18. So we are 18 inches less than normal snow. I haven't even got a snow shovel out this winter. None. Now we had moisture, but it wasn't from this. Now this brings me to an important point. Each one of these big cyclones has come through and dumped all this snow. And the worry is that right now, as of April 4th, this whole region in through here has a lot of snow on the ground. And what did you just see? This whole region is going to add a lot more in the next 24 hours. Some places up to a foot of additional snow, maybe even more than that. When you compare the snow water equivalent map, which is basically what happens when you melt all the snow and have it look as though it rained, there's 2 to 12 inches of rain in this snow right here. And we're about to add more. Last year, it looked like this. We had just had a weak little system come right in through here, putting down just a little bit of snow. But we did not have this much snow in the Red River Valley of the North. There was only a little bit on the headwaters of the Mississippi. And overall, the snow part of the spring flooding last year was minimized. But look at the West. Just watch the West for a second. Ready? This year, last year. What a difference the West sees. But we're back here in the Midwest. I want to tell you something about how you get snow to melt. You got to have sustained warmth, but you got to keep your overnight lows above freezing. Because if you have freezing overnight lows, you put a crust on that snow, which is hard to break through the next day. We want it to be windy. The increased wind enhances the evaporation rate. You want just blinding sunshine as long as you can get it. And you typically want some stuff in that snow to make it absorb more sunlight. There's a lot of folks up here in the northern plains that when they got snow on the ground, they want to get rid of it. They'll just go attach the plow to bring the dirt up on top, because if you do that, the dirt is so much darker, it gets hotter quicker, and you can melt some of that snow. So a lot of folks right now in the northern plains are worried about that. What I'm worried about is not only the snow, but where we currently sit in terms of the ranks since the beginning of this year on precipitation. Everywhere that you see the number 1 is a location that from January 1st up until yesterday is right now having their wettest start to any year on record. And most of it up here, this has all been snow, this whole area. Where are we dry? Well, Florida, along the East Coast, Texas, New Mexico, parts of Oklahoma, and Kansas, right in the heart of our hard red winter wheat belt. Nearly every other place in the country has seen a lot of moisture. If we just hone this in on the last 30 days, the map looks like this. This is a percent of normal map in terms of precipitation. And what you've got here is there's a lot of places throughout the upper Midwest and northern plains, then through the central and eastern Corn Belt, down into the mid-south that's been extremely wet. And while that's all gone on, there's been this corridor right in through here that's been very dry. And we want to know, does this fill in? Because that is the area in the country right now that is still in the deepest drought. So what did winter do? Winter came through and improved our drought monitor from 86% land coverage of drought at the end of November, beginning of December last year, to now just 50% land coverage in some form of drought. But you can see where it is anchored. It is anchored in Kansas, Oklahoma, Texas, parts of Nebraska, Colorado, and that particular area needs more moisture this spring, which is one of the big questions that we're going to answer. Now, I said spring, and I just want to remind you of what time of year it is. This is what time of year it is. It's the time of year where the atmosphere overturns. And what happens typically in April and May is my friends all leave me here in Illinois and go straight to Texas. They go straight to Kansas. They go into Colorado. And what they're trying to do is find this line, which is typically right here, called the dry line. It is one of the most volatile setups for severe weather on the face of the earth. And we had an example of this back on February 26th. Notice though, on the backside of this squall line, all of this is dry and dusty air. I've counted 9 different large dust storms throughout Texas, New Mexico, Oklahoma, Kansas, and Colorado, southeastern Colorado, since the start of this new year. So what's going on this year? The dry line, instead of being here, has mostly been here. It's been much farther to the east. We've had difficulty returning moisture from the Gulf of Mexico back to the west, which is why the drought there continues to get worse. But the bad part about it is we are now in April. If we're going to break a drought that's already in place in the central and southern plains, and we're going to break it in April, May, and June, the atmosphere only knows one way to do that, and that is to send in massive, severe storms. This was one shot in Texas a couple of years ago. It's called the Booker, Texas supercell. It's famous because of how good the footage was of this storm. Take a look right here. Massive rotating rain-free base. It was about to produce a massive tornado, big hail. This is one of the most powerful expressions of weather on earth. And it was just poised and sitting and waiting to just hammer parts of Texas. What I'm trying to tell you is if drought is going to break in the plains of the United States, it will only do it with high impact weather events like this one. Here's another picture of what we're expecting to see more of today and more of going forward. It's already been a very active year in terms of tornadoes. We're expecting the rest of spring to continue to look like that. But I want to remind you something important about tornadoes and high impact weather events. If you've heard me speak in the last 3 years, you've seen the map that's over there on the right. That map over there on the right comes from an article posted in the journal Nature. It's a very prestigious journal. And it looks at where Tornado Alley has been seeing shifts in the frequency of tornadic events measured by their ingredients. We see that there's a shift east, more in the central Corn Belt, more in the mid-south, getting all the way over to the East Coast. That's where the increase in tornadic activity has been. But the map on the right comes from FEMA, and it just shows you where in the United States we're most susceptible to tornadoes. We average around 1,500 of them a year. We have 75% of the world's tornadoes right here in the plains and in the midsection of this United States. And it is just something that we deal with all the time. Those big storms, by the way, that produce tornadoes also produce some large hail. And I've tried to meet this guy a dozen times. He lives in Vivian, South Dakota. He's holding the world record largest hailstone. Now, I could spend another 40 minutes telling you this dude's story, but I just want to remind you, when the atmosphere is going through this active overturning process, and the upper levels of the atmosphere are so cold, we have a better chance of developing more hail early in the season. And the hail threat through the midsection of the country is really on now, but it will last all the way through this growing season, clear through September. We have the atmospheric conditions all the time to produce hailstorms during our growing season. The map on the right just shows you who's most vulnerable. Excuse me, left, the map on the left. One last severe weather thing to talk about here. This was last July the 5th, coming out of South Dakota, ripping across Iowa, finishing in Illinois, is a pretty powerful squall line. Now, this one would have been called a derecho had it been a bit faster and produced more damage. As that moment ripping through this particular area, it did do some damage. In fact, it laid corn down in parts of South Dakota. And by the way, it finished, this storm system made it all the way to North Carolina by the morning of the 6th. But these kinds of squall lines, they're the ones that produce a straight line wind damage. That is the most common form of severe weather in the United States. There's over 15,000 reports annually of straight line wind damage. Do you notice which direction the tail end of this thing curls up? Take a look at it again. We call it the bookend vortex, and watch it spin right there. What direction is it spinning? Counterclockwise. That's because we also refer to these things as mesocyclones. Now, I mentioned the word derecho. And if you've heard me speak, I've shown you this one in the last 12 months, because on May 13th, a year ago, this was the powerful derecho event that went ripping through the mid part of the country. The video was shot in Sioux Falls, South Dakota. And what you're watching here is a derecho event that produced over 600 reports of severe weather, most of them straight line wind damage. I'll never forget this one because my son, I could share with you another half-hour stories about him and this one event here. My son asked me, what's all that stuff underneath that storm? And as we watch it replay here again, I said, this stuff right here? And he goes, yeah. I said, that's Kansas. He's like, what do you mean? I said, that's all dust from the southern plains getting blown clear to Manitoba. That storm system right here, watch it, ready? Rip through Nebraska into South Dakota, hits Minnesota, North Dakota, and finishes in Manitoba and Ontario. Just an absolutely massive and powerful storm system. That derecho moved in this direction. Most derechos move in this direction. One of my former students, Corey Gaustini, put together the first climatology of derecho events in North America, and he found that the hotspot for them is right here. May to August, this is the corridor that has the most active derecho events. On average, the return time period is 1 in 6, meaning that your probability of having a derecho in any given year is 1 in 6. Please remember that. Now, we're going through this relatively quickly just to remind ourselves of what time of year it is. I want to spend the back half of this talk telling you about the opposite of this, because I realize in farming, we still have to get work done. But the way the atmosphere can get ready for us to really just plow forward and get stuff going is to get rid of the stuff that spins cyclonically and bring in the stuff that spins anticyclonically. Now, I'm going to tell you something. Anticyclones are only welcome in spring and in fall. We don't like them in winter. We don't like them in summer. We only like them in spring or fall. And by the way, the picture you're looking at here, this is just that famous picture from Canada a few years ago. This guy says, I just had to get the grass cut. He says, I was keeping an eye on that tornado. Everything was fine, but the lawn need mowed. So I had to get some work done. That's how I feel like we are in ag all the time. We just got to get work done. So now listen, we just walked through the setup of what we've already seen. What I'm going to tell you is we need anticyclones to start to show up more often than they have to slow this whole sucker down. But then I want the anticyclones to go away for summer. I need you to know that point. We then forecast for spring and summer, quickly cover South America, and then we're out of here, okay? So here we go. The hunt for the anticyclone. This animation doesn't look like much, does it? But where you are is back a few weeks ago in late March, where a big area of high pressure set up right here. Doesn't look like anything, does it? But what was going on was this high pressure cell, an anticyclone spinning in this direction. See the difference? It began life in Siberia and had moved all the way here. And what it did was prompted across all of these states in the Southeast freeze warnings. And those freeze warnings meant that the South had a frost event that got all the way down to the coast, and it damaged some of the crop down there. It also impacted, I'll go back to this map here, places that had some winter wheat in Illinois, Indiana, Kentucky, and Ohio, because the winter wheat crop was actually pretty far along into spring, because before this event, this whole region into the Southeast was very warm. But we measured over 48 hours in this area with a temperature below 29 degrees Fahrenheit, which some estimated was cold enough to cause some damage to that winter wheat because of how far along it was. Why was it so far along? Well, before that, it was measured by the National Phenology Network that spring was up to 20 days earlier than normal, some places more than that. You say, well, why was spring so early down here? It was early because of this, a big subtropical anticyclone. You see, subtropical anticyclones bring in warmth. The ones that come from Siberia bring in cold conditions, but they all spin in this direction, clockwise. And that's the one that pumped all that warmth early in the season before it was replaced by a big anticyclone that came down out of Canada. Now, let me go back even further. This map looks unassuming, doesn't it? But it's January 30th into February 1st. Big high pressure cell set over parts of Texas. Doesn't look like much, except this was incredibly cold air from the Canadian archipelago that finally made it all the way down to Texas. And underneath it, we had ice cold air with warm air aloft, giving us the mix to give us some sleet. There's some view of what sleet looks like. Ice storms got all the way as far south as Austin, Texas. My former business partner and close friend, Bill Chapman, took this picture for me, showing me over an inch of ice in Austin, Texas. You know what was funny? That's an area that's been in drought. And people down there which sustained the damage from this from this ice event said at least it brought in some moisture. But just to let you know something, every time they have to de-ice an aircraft, the aircraft loses a significant amount of its revenue because it costs money to de-ice it and it delays the flights. This is what it looked like down there on some of the major interstates. They do not have the equipment to move the ice. So what happens is lots and lots of car accidents. And I told you at the beginning of this report, I want you to be using my weather reports. I know for a fact that Mr. Dove here does not. His wife sent us this video. Why do I know he doesn't read my reports? Because we talked about this ice storm for 7 days before it happened. And he wakes up in the morning with his coffee and doesn't know that ice is accumulated right there. He knows it now because he cracked the back of his head pretty hard. And I hope that now he starts to read my reports. But this just tells you these kind of events can be highly impactful. All of this born on an anticyclone. That's how they work. By the way, here's another great one. A big anticyclone in the middle part of the country pushed winds from the west across the Great Lakes last November. That's all anticyclone wind. And as it went across, it hit Lake Erie and blew up this 3-day-long lake effect snow event that looks something like this from the side. All of this is lake effect snow, hyper narrow focus band of it, where you're sitting right here, a dusting down the road, 6 feet of lake effect snow. And I've got a lot of people worried that an anticyclone might set up over the southeast in late April, in May, and in June. And the reason why they're worried is because the last time we saw a big anticyclone here in spring, low pressure systems came around and went around the edge and followed the flow around the anticyclone like this. The anticyclone opened up the Gulf of Mexico to moisture. And in 2019, the near constant permanent position of this ridge brought in the flooding rains across so much of the Corn Belt. These are some pictures of where the Missouri River blew out all of that ice, destroyed a lot of infrastructure, destroyed roads, bridges, dams in Nebraska, and also flooded out the Mississippi River. That was taken in St. Louis. I took that picture. Water comes up 3 more feet on these steps. It breaks the record set in 1993. What I'm telling you is without that anticyclone, those storm systems wouldn't have followed the same track. So here we go. Last year, a massive anticyclone sat over Texas, dried it out. This is a cotton field that never got planted because of too much heat and too much drought. How often does that happen that cotton doesn't get planted because of drought? Cotton is a very drought-resistant crop. It's amazing to think about it. But I need to pull everything I just taught you into one important statement, okay? So listen very carefully. Cyclones, anticyclones, low-pressure systems, high-pressure systems. We need right now for a big anticyclone to sit over the midsection of the country to get the snow to start to melt, to get the spring field work going by raising the temperatures in the soil, and to stop these big systems. But do you remember what I said a few moments ago? We want them to go away, get rid of the anticyclones once we're in late June. And this is why. Listen very carefully. Last summer, look at this map right here. This is mid-June to late July. We produced the hottest and driest summer conditions from mid-June to late July on record from Missouri, Arkansas, Louisiana, Texas, Oklahoma, and Kansas. Drought was still present in parts of Iowa, Minnesota, the southeastern quarter of South Dakota, and Nebraska. We had pockets of drought elsewhere, but the greatest drought was right here in this area. Now you say, why? Guess what? That's where the anticyclone sat. This is the most feared weather pattern that anyone can forecast for a growing season. We call it the triple ridge or the triple anticyclone. Now listen to me carefully. The top thing I will be forecasting after you all get a crop in the ground is this. I'll be watching for a ridge of high pressure in late June to develop between Hawaii and the Aleutian Islands. If I see this ridge developing, red flags and alarm bells go off in my head, because when the atmosphere does this, it also tends to produce another ridge in the Midwest and another ridge south of Greenland, the triple ridge. Do you know why we call them ridges? They're called ridges because they literally look like a mountain chain of air in the atmosphere, preventing, in this case, moisture from getting from the Gulf of Mexico into the ridge. It goes around it instead. That's it. This is the most feared weather pattern. Now, if this ridge doesn't set up, the likelihood of this ridge setting up drops off. Same with this one. And we don't want any of them. We want the atmosphere to stay open and regular and flowing and not get blocked up into ridges. So if you've ever heard an atmospheric scientist use the term block, we're talking about the way that ridges block the flow of the atmosphere. That's why I'm telling you about anticyclones today. We don't want this. Now, in fall, we have to look for them again. Last fall, the biggest ridge sat right here, and the flow went way over the top of it. And as that flow came out of Canada into the midsection of the country, for a few weeks in September and October, I was pretty excited about this. Wide open harvest windows. Why? No cyclones, just anticyclones. But the problem became that when this ended up lasting for almost 2 months, the soil moisture was zapped in the midsection of the country. And we saw soil moisture percentile drop off, well, to where much of the country was down to below 2%, right in the heart of the United States. Now, since then, most of this moisture is recovered, but this was the same system that produced the flooding, the drought on the Mississippi Basin. That's in Memphis. You can see the sand on the other side. We've never seen that much sand in that part of the river in this spot. And then here's a barge, one of the last ones that tried to move through. And as it did so, got too close to the edge, trying to stay in the deepest channel. And the resulting impact of this was that it put part of that barge up onto the shore, actually knocked this guy's fishing pole over. It's amazing to see what anticyclones can do. And the one place where the anticyclones keep showing up is in the central plains of the United States. So while the Mississippi River has made a full recovery from last year, in fact, it's flooding in certain places, back in the Western Plains, not the case. That dust storm we just saw in satellite looked like this last December. 60 miles an hour, dust hammering a winter wheat crop. And you just saw the other day that the condition of that winter wheat crop showed up at the lowest it's ever been. And why? Because over the last 30 days, while cyclones have done this, anticyclones have sat right here. Now do you get it? I went through an entire 40 minutes so that you know how big of a nerd I am and how all I care about is the way the atmosphere spins. I've got 20 more minutes to make a story out of this for you and to show you a forecast. So buckle up, let's get this thing finished. Our drought monitor still looks like this. And if we have a big anticyclone that sits in this part of the country this summer, all of this fills back in with drought. So this is about the avoidance of an anticyclone for the next 6 months, okay, when we get into the growing season. Now, February, March, April are my favorite times of year to forecast because it's the time of year that no matter what, everyone forecasts a massive drought for the upcoming growing season. They do every year. You have people that don't even know anything about weather who just say that they know what the upcoming summer is going to look like. And it drives me absolutely nuts that people do this because the reality is none of us know what the upcoming summer is going to look like perfectly yet. We have ideas, but a lot of people talk about them with certainty. And that is just, you shouldn't do that. My favorite thing about living in the Midwest is everybody likes to compare the upcoming forecast to the most recent terrible weather that they've seen. So where I live in Illinois, and for many of you watching, they're like, oh, is this year going to be just like 2012? Because that's what the corn yields look like in Illinois. Before that, you remember the year we compared it to? Before 2012, it was, is it going to be as bad as 88? where the Mississippi River was so low near Memphis that they found old shipwrecks in it. Before that, it was like, oh, is it going to be as bad as 83? Or what about 1980? You can actually get a t-shirt out of Texas that says you survived the heat wave of 1980. Before that, it was the drought of the 50s. Before that, it was the Dust Bowl. Everybody at this time of year wants to make a projection about the season in the middle of the year and forget about the one that they've got going on right now, the spring one. It drives me nuts. But I get why you do it. Why, not why you do it, but why it is done. We do it because when we look historically, no other weather phenomena has shaped human existence more than drought. None. No other weather phenomenon. And it's because drought doesn't kill you by just drying you out. It kills you through war or mass migration or by famine. You look at the top 10 disasters, natural disasters in human history. Notice there's no earthquakes on this. There's no flooding. There's no big cyclone. It's all anticyclone driven famine. That's it. And I understand why that's the case. I'm going to give you just a 2-minute story on what I call the best weather forecast of an anticyclone in human history. You ready for this one? It's one of my favorites. Rewind the clock 3,500 years ago. Find yourself in Egypt in the bedroom of the Pharaoh that was in charge. He had a dream. And in his dream, which was really more of a nightmare, he said that there were 7 fat calves in his dream and 7 emaciated calves. And the emaciated calves ate the fat cows, but didn't get any healthier upon doing so. He wakes up in a cold sweat from that nightmare, has no idea what's going on, tries to fall back asleep, and does so. In the second part of his dream, he dreams of 7 healthy stalks of grain and 7 terrible looking stalks of grain. And the 7 terrible ones consume the healthy ones and don't look any better after they do it. That time he wakes up and he's very much in a panic, and he calls all of his best advisors and asks those advisors, what did this dream mean? I need to know. And none of them could properly interpret that dream. But it turns out he had a butler who had just spent some time in prison. And that butler said, well, there's a guy down in the prison cells beneath us here that's been interpreting dreams for prisoners down there. Pharaoh says, bring him up. So they bring up this young man. He shows up in front of Pharaoh. Pharaoh tells him the dream. And the young man named Joseph, interprets the dream as this: there will be 7 years of abundant harvest, great weather, and 7 years of anticyclones, drought, famine, and problems. Pharaoh says, Joseph, why are you in my prison cell? He says, my 11 brothers sold me into slavery. Pharaoh says, what should we do about this upcoming 14-year time period? Joseph says, every year for the next 7, store up extra grain, 50% extra, or excuse me, 20% extra. Do that so that by the time the famine hits 7 years from now, we've got enough grain to survive it. Pharaoh says, who should I put in charge? Joseph, standing right in front of him, ends up getting the job, goes from being a prisoner to becoming prime minister, probably in about an hour. Now, what's great about this story was 7 years of abundant harvest goes by. Joseph stores up grain. What happens after that is that his family, the ones that sold him into slavery, leave Canaan to go to Egypt, the only place to buy grain during the famine. When they get there, Joseph recognizes his brothers, but they don't recognize him. Joseph says, go back to your homeland, bring back your father and the youngest brother, and I will give you land and give you food, and you can stay in Egypt. So they went back, got dad, came back, massive family reunion. And what's amazing about this story was that family of 12 boys and 1 sister, but 12 boys and 1 sister, ended up growing to having a population of over 3 million people in the 400 years that followed. The head of that family, his name was Jacob, got a new name in the process. His new name became Israel. And that is where the Israeli people are from. They came out of Egypt, and that was the topic of this movie right here. 400 years later, this descendant here, Moses, and here we have Yul Brynner playing Pharaoh, they get kicked out of Egypt. 3,500 years of Middle East strife was because of mass migration due to famine. Now, here's what I'm going to tell you. I've got 11 minutes to make a case. And in the next 11 minutes, can you please remember that I am not Pharaoh? I cannot forecast perfectly months and years in advance. And to make sure that you understand that weather forecasting is still incredibly challenging and long-range forecasts are speculative and that you should never bet the farm on a forecast, I'm just going to remind you that still every year we have a tradition of consulting a would-be hibernating rodent on its opinion of the upcoming forecast. Please do not forget that overall. All right. Now, this particular video was shot of this groundhog that likes to eat this farmer's produce right in front of his trail cam. I find it absolutely hilarious, but we need to move on to bigger things. It has been cold in the West and it has been cold in the Midwest. It's only been warm in the Southeast. And so if we're going to ask what it takes to finally warm things up, this is what it's going to take. You guessed it, a big anticyclone. If you are a Midwest grower in this area, the best thing that could happen in April is the jet stream comes screaming through the Aleutian Islands, dips down into the west, and then builds into a massive ridge that extends all the way up to the Hudson Bay. That is what we want. This is what we're looking for. Now, at the end of March, I thought there was no hope to see this in April, but my hope is beginning to improve. Now we get nerdy. You ready for this? This is the big trough of low pressure, the cyclone that's providing the lift for the massive severe weather outbreak. But watch this. I'll pause it right here. This is Sunday. The troughs now flank the country. And the atmosphere, watch as I click play, is trying to build into an anticyclone right here. Now, if you're not smiling and you're not happy right now, then that means I've not done a good job teaching you. That means the atmosphere is about to warm up in a big way in the middle part of the country. That also means that these deep low pressure systems like this one, that's the last big one we're going to see here for a little while. Going through this weekend into next week. Notice there's no major central US massive storm systems, quite possibly for about 10 days. So where's it going to be wet? After this system rolls through, the one that's today and tomorrow, it's primarily wet down here in the south and along the Pacific Northwest coast. But the good news in the forecast is this. Are you ready? This is the next 5 days of temperature anomalies. When I click play, we're going to slide through a 15-day forecast. Ready? And what you notice is, see the warmth coming in for mid-April? The only thing I don't like about this forecast, ready? See all the warmth coming in for mid-April here? This all gets here very soon. That warmth that comes in fades at the very end of the forecast for the West. And we expect the atmosphere to go back into dipping in the West and ripping through the central part of the country. Say, well, what's wrong with that? When the jet stream does this, low pressure systems spin up and follow that line right there. And therefore, while we're going to get a break from all the severe weather here in the near term, we do expect it to come back. So here we go. Ready? I saved this for the end, hoping that you'd still have some coffee left over because we need to talk about what this pattern looks like going forward. We actually now see from mid-April to mid-May, more warm air advancing in this area. What we also see is that everywhere inside of the arrow that I'm drawing over here on the right image, I expect to be wetter than average. Now you're going, wait a minute, Eric, I see dry in through here. Nope, that will not be drier than normal. We'll see tighter windows in there. I do not want to see this. That's above average precipitation with below average temperatures, which means the rate at which we're going to melt the snow in the northern plains is likely going to be slower than any of us want it to be. Now, there's a good thing about slow melt. It actually reduces your spring flood, but we've got like 45 days in which to get things going. And unfortunately, the atmosphere is trying to keep that away from us in the northern plains. Notice that the forecast for the whole of the month of April, it starts off this way and it finishes this way, means that there will likely be more severe weather into this corridor. Chances of continuing the drought in the central plains is high, but repeated shots at warmer air advancing through the Midwest, into the upper Midwest, into the northern plains, but more frequently bringing in colder air behind it. But I want to remind you of something very important. The atmosphere can change on a dime and none of us can see it coming. So let me give you an example. This was April statewide average temperature ranks in 2018. Iowa, Wisconsin, coldest. Surrounding states, second coldest. May was record warm. The atmosphere can do that in a heartbeat, and we're going to watch out for that. What a lot of us are concerned about is prevented plant acres. Last year, we had 3 main areas of prevented plant. This part of the Central Plains, that was drought. This part of the lower Mississippi River Valley, this was severe weather and flooding. And this part of the Red River Valley of the North, that was all driven by massive areas of spring flooding, not from snow, but from flooding rains. We don't have to have another drop of rain in the Northern Plains to have a flood fight. And earlier this month, the NOAA, National Weather Service, released their spring flooding outlook. They've got a lot of flooding along the Mississippi River here. They will probably increase this part of the Red River Valley of the North to becoming major. And darn it, I forgot the name of this river. Is it the Big Sioux? I'll have to go back and look it up. But the one that goes through Sioux Falls, that river right there will probably go back into the major category as well. Going from there, we have lost this. This is what the anticyclonic flow looked like driving a La Nina for the last 3 years looked like. It's gone because back in December, all of this cold water associated with La Nina looks like this today. We've already lost it. My only fear left of summer heat and drought is this. Now listen to me carefully here. If you are in the midsection of the country where I put that X, if these cold water temperatures fade between now and July, that is the best possible scenario for us to avoid the risk of major drought in the midsection of the country. This is your only surviving signal of major drought redeveloping in the midsection of the country. So we're going to talk about that as we wrap this up. Because here, where we watch for El Nino and La Nina, every major long-range weather forecasting system says, bring in El Nino conditions by summer. This is from the Europeans. This is from the forecast from the Australians. I could show you the United States forecast. They all do the same thing. And why this all matters, and this is where we get to the end of this. It all matters because of this. I understand that a lot of you watching are representing the Midwest, the primary corn and soybean belt. Some of our worst years on record, see them all listed right in through here? Worst years on record had major soil moisture problems that lasted through spring, from the Red River Valley of the South to the Red River Valley of the North, from Nebraska all the way over to Ohio. These years had a common signal. Spring rains did not undo drought in those two areas. What do we have this year? A tremendous amount of snow, severe weather and heavy spring rain, and the drought is only anchored in this area. So we've eliminated 2 of our preseason worries. The other one is this. All of the cold water that we had during these terrible summers for growing crops, this is all gone. The only place that it remains is right in through here. That's the only thing left for us to worry about is the cold water off the west coast of North America. But if this happens, are you ready? Here's March. If this happens, where El Nino builds and the cold water fades, we will go into summer with above average precipitation for many of you that are watching on this call. So April, May, and June, we expect tight planting windows throughout a big section of the country, but warmer conditions starting to show up. In fact, the US models show that warmth really getting here once we get past the end of April and sticking around through that point in April. The forecast models that look out again April, May, and June also show above average snow here, or excuse me, not snow, above average temperatures going through April, May, and June with less additional precipitation. But we need to get this distilled down into some simple maps. Here you go. I agree with the CPC. If there's a place that hangs on to coldest air the longest, it's going to be where the snow is. More mild conditions are on their way for a lot of us. The problem is tight spring windows due to excessive precipitation. That's what you've got in this part of the country. Drought concerns primarily stay anchored in parts of western Kansas, Oklahoma, Texas, New Mexico, and Colorado. Everywhere else in through here, we're expecting drought to improve. Now, as I finish this up today, I want to remind you of something. Last year, the models did a pretty good job at picking up on the fact that along the Mississippi River, to the west of it, drought risk, to the east of it, better chances of moisture. It found that in March. This is what it's got right now for June, July, August. Guess why it's wetter there? There's an El Nino, and El Ninos reduce the risk of anticyclones. This is what the US models are saying. So as it stands, to finish this up, this is what I want you to see. We have an El Nino coming in. And if you think about corn and you go all the way back to 1970 and look at detraining nationwide yields, these are the years that had El Nino events during them. And of the 17 El Nino events that we've had since 1970, only 3 of them have produced below trend yields. That is still possible this year, but I am not Pharaoh. I cannot predict it out that far to tell you with any sort of accuracy exactly how the summer is going to play out. What I'm telling you is, because of all of the things I just mentioned, we have a lower risk than average of having massive anticyclones in the midsection of the United States this summer. Now, I did not leave time to tell you about Brazil, but I can give you 15 seconds of it. Are you ready? This is what I want you to think about. Brazil's got a safrinha crop in. The rains look fantastic, except for Rio Grande do Sul. Argentina, which is down here, has better rains coming, but it's too late. The drought was too long and too extensive in that area. Plus, they had a frost on February the 18th in parts of Argentina. That's your story in South America. Big soybean crop, big safrinha corn crop. It's off its normal crop calendar by about 2.5 weeks, though. Okay, Matt, I went 12:01. I'm sorry. I'm going to stop there. I can take questions if you got them, but we'll leave it.
I have one question for you, and then we'll take some questions here that people write down. But that last graph that you showed, the number of El Nino years that were above trend line.
Yep.
I was always told that in El Nino years, 70% of the time you have above trend line yields. And I look at this and I think, well, that's maybe about right. Would you agree with that? 70% of the years in El Nino are above trend line.
That's right. But remember, we have to think about this holistically. So that means 30% of the time it's below, which means 3 in 10, you do get a below trend yield, which means we still are not set on what this summer is going to be. But right now, the signs are looking positive. We just have to get the crop in.
Yep. Okay.
All right. Were there a couple questions?
Yeah. Is someone asked, as you see things now, what kind of odds would you give that triple ridge phenomenon developing for the Midwest this summer?
Yeah. Last year, the odds were at 60%. This year, they are closer to 40%. In fact, we got up last year in late May. The odds of seeing that were actually over 70% last year based upon what we saw through late May. But now this year, at this point in early April, like I said, we're down there around 40%, and I expect it to go down if we continue to see this El Nino really start to rear up and show itself.
Yeah.
That's a good question.
The question is, or maybe it's just looking for a comment. I think Elwin Taylor's Midwest weather work was based on the 90-day SOI being in El Nino or La Nina. Most of the discussions I see are saying that the 30-day SOI is projected as El Nino by midsummer. Please comment.
So the Southern Oscillation Index, so we often give, this isn't saying anything about Elwin Taylor, but I'm just saying you can't base your whole forecast off of one thing. The Southern Oscillation Index, all this is doing is it's measuring the pressure difference between, look at this, I'll just show it to you real quick, between Tahiti and Darwin. So it's measuring the pressure difference between here and here. That's it. That's all it does. It's a measure of the trade wind strength in this one spot. That's it. That's all this does. When the Southern Oscillation Index is above 7, we consider it to be La Nina. Look at what it's been doing. It's now down to -4. So that's just one indication of what's going on here. If the Southern Oscillation Index keeps going down, well, I'll just show you why we care about it. Okay, let's do this real quick. U.S. climate divisions, U.S. climate divisions. I'll go here. What I want to show you, sorry, let's go back one more step. I want to show you this one. And we're going to say precipitation, I don't know, let's just do May to August, Southern Oscillation Index. So what you're going to see is everywhere that there's blue, there's a negative correlation. So what happens is When the Southern Oscillation Index is high, this area is in drought. When it's low, it's dry. I'm sorry, it's wet. It's wet. Where is it dry? Here and here. So that's why there's a lot of emphasis put on the Southern Oscillation Index. But the Southern Oscillation Index is really a measure of El Nino or La Nina. That makes sense?
Yeah. Maybe I don't know. People are kind of shy. Don't see any other questions, but
Well, I also
I
bombarded them with information for an
yeah,
hour.
yeah, they're trying to soak in all your wisdom. So, but it looks like we're headed for a warmer spring. But as you said, that can change on a dime. I mean, it was interesting how you pointed out that was that last year we had you know, record cold to record warm, and just from 1 month to
2018,
the
yeah.
next. That was 2018, yeah.
2018, yeah.
Yeah.
Yeah, so what I would say here is that when the pattern breaks, it's going to break fast, and we're going to have to be ready to go and go aggressively. There's still a lot of cold air stored up to the north over the last 30 days, but just take a look at this. This was just released a little while ago. This is the newest forecast from the GFS model. This is day 5 through 10. Look at these temperatures here, up to 15 degrees warmer than normal. And then this is day 10 through 15. Very mild conditions. And I did not do a good job at forecasting this about 3 weeks ago. I thought that the front half of April was going to be colder than it was. So that just shows you how difficult it is to look out here this far and figure. That's why every day I write a report so you can watch the evolution of the forecast.
I have one more question that came in. Is there any correlation between ice-free Great Lakes and dry weather in the Midwest?
No, not between dry weather in the Midwest. Ice-free Great Lakes does tend to promote an earlier arrival of spring in this area. But generally what keeps the lakes ice-free is the jet stream doing this, like I've been showing you today. It's zipping through. That's too much mild air. And that actually tends to keep this whole area very active with severe storms and wet weather. So I think it would actually be the opposite of that. But the correlation is very, very low. Good question. I like that one.
Yeah. Last question here. Then I know you got to take off. How much of a problem do you anticipate getting the crop planted on a timely fashion this year? So I think, as you kind of pointed out, I mean, the main concern is in the Dakotas right now, but they still have, you say, 45 days before things are going to be start to be considered late.
Yeah.
And that's why there's a lot of snow there. Things are warming up, here fairly soon, and so it should give them some time to dry out. But I don't know if you have any final comments.
That's where the problem is going to be. But I'm coming into my weather forecasting system here. It's called agweather.com. I just want to show you something. I went ahead and I went out to Ames, Iowa, just as this first town that popped into my head. And if you come out here and get your forecast information, there's down at the bottom some great things here. And I'm going to show you something. If you click on this radio button right here called year-to-date GDDs, which, by the way, Ames is having its wettest start to any year in the last 6. So that's important to know. But if you click on year-to-date GDDs, what you'll end up getting is this graphic. Now, you see these blue bars? That is historically, on each of these days, how many times in the last 40 years we've had a frost event. So our average last frost date is somewhere around April 22nd. But we have had frosts as late as May 15th. So we're still, if we're trying to get out of the risk of a frost, we're still 3 weeks away from that on average. So I know we're all ready to go, but just remember where the atmosphere is and what it means to get going this aggressively. But this is just a GDD graphic here. I actually built another one if you want to see it. It's a corn GDD tool, completely free. You can come in here and select your relative maturity, whatever you want. I don't know, let's pick 115-day corn. Let's say you planted it March 25th and you are I'm just going to pick Dallas. I don't care. If you do that, what it'll do is it'll generate for you. It takes about 10 seconds, but it'll generate for you all of that same information with when we expect pollination, maturity, plus your historic GDD values here. So just want to make sure you all know these tools are available and free. You can get them every morning in my morning reports, which are also free. So, well, Matthew, that should do it, right?
Yeah. Thank you very much for your presentation, and I hope you have a good trip to Nebraska today.
All right, I appreciate it. Hopefully,
We'll send the link out to this later to everyone too. So,
Perfect.
all right, well, have a good day. Thank you very much, Eric.
Yep, you bet. Thank you.